Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to take a look at a couple of deep sky objects, a variety of deep sky objects, hopefully starting with a group of galaxies. So Stellarium, as I mentioned in the previous video, it did recently have an update, and that update included different listings, new listings for things that already existed, and hopefully it may contain some new images as well. So we're looking for Stephan's Quintet, which is a group of galaxies which hopefully comes along with an image. So we're seeing it here in pretty much in Pegasus, pretty much in the hooves of Pegasus. The square of Pegasus is just down here, kind of cut off at the bottom of the horizon. So let's zoom in and take a closer look. So this is a group of galaxies out in this direction. You can see magnitude 13. So technically the kind of thing that would be achievable through binoculars. A lot of the stars here, well, we're seeing these stars are magnitude 6. If we zoomed in a little bit closer, then we would certainly get to see stars that are only 13th magnitude. Perhaps we didn't zoom in far enough. So this is Stephan's Quintet. So it is a group of 5 galaxies. Now that I have it selected, I should be able to stop it floating around too much. Stephan's Quintet is a group of interacting galaxies, or as we can see here, 2 galaxies that are definitely interacting, another 2 galaxies that are in the same realm. All of these galaxies are going to merge together in the near future. This other galaxy, and this other galaxy is kind of in the background. This other galaxy is somewhere nearby. I think this might be an elliptical galaxy. So as we can see here, Stephan's Quintet is labeled. Different ones are labeled in different ways. We can see a little E here for this part of Stephan's Quintet, and that does indicate that it is an elliptical galaxy, although it is the one getting highlighted when we click on interacting galaxy and normal galaxy and active galaxy. So it seems like these other members of Stephan's Quintet are not being included. Really, these 4 galaxies are the main part of Stephan's Quintet, these ones that are blending and merging together. This one is simply another galaxy that's quite nearby. So this group of galaxies, this image that we're seeing here is presumably an image from the Hubble Space Telescope. But this group of galaxies was imaged recently in the past couple of years, back in 2022, by the James Webb Space Telescope. So the James Webb Space Telescope, of course, is a space telescope. It's a telescope that's floating out in space, and it's particularly sensitive in the infrared spectrum. So here's the Great Nebula in Carina, which means it's going to be under the horizon. Of course, the constellation Carina isn't visible from the northern hemisphere. That's not something that's going to bother the James Webb Space Telescope. So this is a nebula that we haven't looked at particularly much on this channel because it is in the southern hemisphere, and I do tend to usually look at things in the northern hemisphere. But we can see here that this is, well, it's a H2 region, so that means there's ionized hydrogen in here. We can see that there's plenty of dark clouds, and those are regions of star formation. We can also see these emission regions, EN, presumably for emission nebula, but that is me making an assumption. The stars in here are hot enough and close enough to the cloud of gas that they're heating it up until it is glowing with this kind of soft pinkish color, which we now know from a few videos ago when we spoke about the colors of stars. We know that this color here is somewhere in the 3000-ish Kelvin range, this kind of a deep red, this soft red color. So the Carina Nebula is another thing that the James Webb Space Telescope targeted. And the James Webb Space Telescope, looking at these dark regions of gas, these dark regions where we're not seeing any stars, they're not holes in space where there are no stars. Those are clouds of dark gas that are blocking the light of the stars behind them, but they are mostly blocking visible light. A lot more infrared comes through these dark clouds, and that infrared is generated by young stars. This is one of the regions where the James Webb Space Telescope has been able to peer through these gas clouds in the infrared in a way that the Hubble Space Telescope using the visual spectrum couldn't. So this is a particularly interesting target. As I mentioned, it is an emission nebula. It's not the only one. We've got plenty of emission nebulas up here in the northern hemisphere. The Carina Nebula just so happens to be one that the James Webb Space Telescope particularly targeted. We're after moving a little close to morning time there. We're going to come back until Orion is just above the horizon. So there's Betelgeuse and Bellatrix, and there's Orion's belt. Looking this far ahead into April, of course, we're no longer seeing much of Orion. But while it's on the horizon, and while we're using software like Stellarium that allows us to zoom in on things, even if they're occulted by the atmosphere, here we can see another emission nebula, another H2 region where a lot of stars get formed. And similarly up here, if I were to remove the atmosphere, it would look a lot more beautiful. So there it is. That's the Horsehead Nebula, the Flame Nebula. These are other H2 regions where young stars are forming, and we can't see them. Their light is blocked out by the clouds of gas, but their heat is still heating up the gas around them, and that infrared heat is infrared emitted heat is infrared energy. It's an infrared wavelength. Really, it is light. When heat radiates, it is light that's radiating. It's just not light that we can see. There are other ways that heat can be transmitted, but not really through space. The only way that heat is coming through space is as infrared electromagnetic wavelengths, and we can't see that. The Hubble Space Telescope couldn't see that, but the James Webb Space Telescope, of course, still is. The James Webb Space Telescope was only launched quite recently, just about 4 years ago. And in that time, it has made numerous discoveries. It's imaged numerous interesting things. But those images haven't made their way into Stellarium yet by the looks of it. I do think that image of Stephan's Quintet and the Carina Nebula are older images that we got possibly from Hubble, possibly from ground-based telescopes as well. I know that the Carina Nebula in particular has been imaged by ground-based telescopes in the southern hemisphere. But one of the reasons that I am bringing up the James Webb Space Telescope is because of the moon. Recently, the Artemis mission, the Artemis 2 crewed mission, went around the back of the moon, but around the back of the moon is where the James Webb Space Telescope always is, or, well, really even further. The James Webb Space Telescope is in a special kind of orbit. It is in an Earth Lagrange point, Lagrange 2. So we're going to head out to the Solar System Observer, and we're going to look down on the Earth-Sun system. We might not be able to see, yes, we can see the Earth and the Sun at the same time. I'm also going to bring up the orbit of the Earth, because the orbit of the Earth is really what we're interested in here. So there's the orbit of the Earth around the Sun. Normally, if something orbits closer to the Sun than the Earth, it's going to orbit faster. For example, Venus, significantly closer to the Sun than the Earth, it's going to orbit the Sun faster. Its year is shorter than ours, and then again for Mercury. However, if you place something in just the right spot, a little bit closer to the Sun than the Earth's gravity will essentially stabilize it. Any object that is just inside the Earth's orbit will orbit the Sun with the Earth. That's the first Lagrange point. The second Lagrange point is just out on the other side. Normally things that are further from the Earth, like Mars, which is out there, but of course not particularly bright, so Mars isn't showing up here, but Mars is out there. Mars is further from the Sun than the Earth. It orbits more slowly. Its year is longer. For objects that are in just the right place, the Earth's gravity pulls on them and essentially helps to pull them around the Sun at the same speed as the Earth. So that's where the James Webb Space Telescope is. It's hanging out at a point, L2, or the second Lagrange point, and that is a point that orbits the Sun with the Earth, even though it is further from the Sun than the Earth, and generally we would expect that to cause things to slow down. There's a couple of other Lagrange points. The third one is on the opposite side. So an object that is directly opposite the Earth from the Sun will be in a stable point where it orbits the Sun at the same speed as the Earth. That one isn't very useful for us because it's very difficult for us to communicate with objects that are on the opposite side of the Sun. It's also difficult for us to communicate with objects that are on the far side of the Moon, but of course the Moon is orbiting around us. The James Webb Space Telescope is fixed in that location opposite the Earth from the Sun. So that does mean on a full moon, the James Webb Space Telescope is pretty much behind the Moon from the Earth, but as the Moon orbits the Earth, the James Webb Space Telescope stays exactly where it is. There's two other Lagrangian points, 4 and 5, or 4 and 5. I don't know, left or right, top or bottom, it doesn't really matter in space. Either side of the Earth, there are two sort of kidney bean shaped regions where objects can orbit being influenced by the Earth's gravity and the Sun's gravity in such a way as that they orbit with the Earth, or following the Earth, or ahead of the Earth, orbiting with it. The three first Lagrangian points, 1, 2, and 3, they're kind of small points, whereas L4 and L5, they're more regions of space in which things can be stable. Jupiter, in particular, has a lot of asteroids at its Lagrange points, the Trojan asteroids at L4 and L5. I think it's the Trojan and the Greek asteroids, one at L4, one at L5, but those are objects that are naturally trapped in the Lagrange point. The James Webb Space Telescope is, of course, an artificial satellite that we have put out there in space. Just a couple of deep sky objects and a little bit about the James Webb Space Telescope, because it is, of course, quite far from the Earth in that stable location, even further than the Artemis 2 astronauts just travelled. But of course the James Webb Space Telescope isn't crewed. There is nobody on the James Webb Space Telescope. So hopefully we'll talk more about that, and maybe about the Jupiter Lagrangian asteroids, the Trojan and Greek asteroids, in a future video. But until then, I hope that you enjoyed this video. If you did, please do like it. If you like this kind of content, then please subscribe to my YouTube channel. And if you'd like to read this information, you can do so on my website, queevinscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.